Hello, everyone. Namaste, good morning, good afternoon, and good evening. Well, it's evening here in Nepal. It's GMT plus 5:45. I hope you are doing all great. This is Suraj Gautam, a civil engineer and a DRR professional from Institute of Himalayan Risk Reduction, and I'll be your host for today's session. First of all, I'd like to welcome you all to our third episode of webinar on Geoscience for Sustainable Development. Well, IHRR has been regularly organizing Himalayan webinar series under the two themes. One is regarding geoscience for sustainable development, and the other is disaster risk reduction. Under the webinar series of Geoscience for Sustainable Development, we have successfully organized two sessions, two webinar sessions, which can be which is also available in our YouTube, which will be sharing in the session. And it's time for the third now. The topic for today's webinar is importance of optimizing geodatabase for developing countries and its application for disaster mitigation strategies, which will be presented by Dr. Rama Mohan Pokhrel. On behalf of the organizing team, we are really grateful to our speaker who will be sharing us with his insights and healthy experiences. So we would like to welcome our speaker, Dr. Rama Mohan Pokhrel, who is a senior research associate at Department of Civil Engineering, University of Bristol, UK. The session will be moderated by Assistant Professor Dr. Basanta Raj Adhikari from Institute of Engineering, Tribhuvan University, and who is also the visiting scientist of Institute of Himalayan Risk Reduction. It is indeed an honor to have insights from our distinguished speaker. Also, we would like to welcome all our participants who are attending this session. This webinar event is also featured in the Prevention Web website. Regarding the webinar registrations, so far we have more than 217 registrations from different corners of the globe. To address this request, we are going live on our social media page of Institute of Himalayan Risk Reduction, and we'll be receiving the queries and feedbacks from our social media live stream as well, and also from the Zoom chat box. So ISRR has been organizing this webinar series on geoscience for sustainable development on a regular basis. We believe this webinar series has definitely has been supporting our early career scientists, DRR professionals, professors, and all the participants. And yes, it's just a beginning. We will have a long way ahead. So before starting our series for today, I would like to share some brief introduction about our institute, that is Institute of Himalayan Risk Reduction. So let me share the screen. Institute of Himalayan Risk Reduction is a research institute established with an objective to assess and understand the risks to contribute for the sustainability. Complying with the Sendai framework for disaster risk reduction, IHRR envisions to understand the risks and application of interdisciplinary knowledge with science, engineering, technology, and innovations to contribute for risk reduction and bridging of academic research with professionals and policymakers for the sustainability. So our team constitutes of professionals with expertise and experiences in the field of disaster risk reduction, in understanding the risks, conducting academic research and field level implementations in Nepal and across the globe. So far, we have been engaging in a number of projects, like we collaborated with a team during this COVID-19 response, where we contributed from our side in developing a national platform for COVID-19 response. This is what we just did recently. And also we have been collaborating with the local governments to bring out the frontier technologies such as UAV surveying. And the work has been done in Hetauda sub-metropolitan city for the very first time. Similarly, we have had quite a number of engagements, and we are also advocating the recently promulgated DRRM Act and trying our best to collaborate and contribute. We have also published this voluntary commitment in the Sendai framework. You can also view it from the Sendai commitment website. And yes, this is what we have been doing, organizing some Himalayan webinar series. And this is the topic for today. And now I would like to share some house rules for this webinar. The audio and video of the participants will be switched off. For any queries, the participants can write up in the chat box or in the comment section of Facebook streaming live. Waiting rooms have been enabled, and I would like to request our participant to please rename their name as they have mentioned there in the registered link, because we won't be allowing the user with unknown names. Similarly, the feedback link will be provided during the session, and we'll be taking some questions from our participants. And without any delay now, I would like to move on to our session. And may I request Dr. Basantaraj Adhikari to proceed further with his moderation. Thank you.
Thank you, Suraj. Am I audible?
Yes, sir, you are audible.
Thank you, Suraj Gautam, Executive Director, of Himalayan Risk Reduction, and it's indeed a pleasure to moderate this session for today. And this Geoscience for Sustainable Development is a forum where we invite national and international experts to share their ideas, their research, their understanding, how we can use the knowledge of geoscience in the field of DRR and DRM and other beyond the borders, or in other categories also. So this is our third webinar series session, and today we are going to have Dr. Rama Mohan Pokhrel. We are working together for a long time, and we know each other, from our university days. And now he's a senior research associate at the Department of Civil Engineering, School of Civil Aerospace and Mechanical Engineering, University of Bristol, UK. So he has completed his PhD from Geosphere Research Institute, Saitama University, Japan, and postdoctorate from the Institute of Industrial Science, University of Tokyo, Japan. And his main interest or research interest focuses on geohazard mitigation, engineering, and geospatial simulation and modeling. And he's quite well-known researchers in this field and published more than 70 international publications in peer-reviewed journals and book chapters and books. So he has been doing his research in the Nepal, Himalaya, and adjacent region. So his specialty on this understanding of broad range of geoscience, how to use the different geophysical techniques, how to use the different disaster database for the sustainable development. These expertise which he has are really important for us to understand and to implement his findings and to involve him for the national building process in Nepal and beyond. That's why you have invited him as a speaker today, and he accepted our invitation. And so for that, I would like to thank Dr. Rama Mohan Pokhrel and want to welcome to give a presentation on importance of optimizing geodatabase for developing countries and its application for disaster mitigation strategies, which is really important for us. Some countries we have big database, and some countries we don't have that database. But how can we use such kind of data scarce region and data rich region for this optimization of information for geoscience risk reduction? So once again, thank you for Rama Mohan for accepting our invitation, and I would like to welcome. And Dr. Pokhrel, the virtual room is yours. Please proceed.
Yeah, Basanta?
Yeah.
Can you hear me? Okay, thank you.
Yeah.
Thank you very much, Basanta, for inviting me for this opportunity to present, to share my knowledge to all the geoscientists working in the Himalayas and in Nepal. Yeah, today I'm going to share my knowledge about importance of optimizing geodatabase for developing countries and its application for disaster mitigation strategies. Yeah, I'm Rama Mohan Pokhrel, Senior Research Associate at Department of Civil Engineering, University of Bristol, UK. And yeah, I did some work in different countries in Japan and in Nepal. Therefore, actually today I want to share in the how important is the database to prepare our maps or our strategy for the disaster mitigation. Therefore, if there is no data, no availability of the data, no sufficient data in any countries or any area, how can we solve the problem and how can we minimize this scarcity of the data is my theme to share with you. Yeah, yes, such kind of disaster is very common in the mountainous countries and become our nowadays the people think is our destiny. Therefore, we all are aware that there are possibilities to change this destiny. We can save our lives and our built environment. Therefore, mitigation measures are impossible without in-depth knowledge. We know that without depth and knowledge, we cannot mitigate these kind of disaster in the Himalayas, not only Himalayas, in all around the globe. Therefore, in developed countries, we can find some data they stored from the long time, from the history, and then they can use these database for the future research as well. But in developing countries, there is a lack of data, lack of this kind of culture to store the data to in the different forms, like what kind of information they have, because the data are not the only numbers or only reports. They can be the different types of informations. For example, the photographs from some sites, some geological maps and reports, or geophysical maps or geotechnical maps, engineering geological maps or aerial images, geological, geophysical or geotechnical investigated data or investigation data, lab test results. Yeah, these kind of information are the database. Therefore, any kind of information related with soils from our interested area, they are the database. Therefore, these database can be used for the future. Therefore, I want to show how important if the number of data or information helps to predict the maps or predict the disaster, predict the future problems with this area is the main theme I want to show in these presentations. In the next slides. Therefore, for this in today's presentation, I want to share the informations, the studies did in Japan, because in Japan we can find the data whatever we want, large number of data or less number of data. Therefore, I want to show you if we use the large number of data, what kind of results we can find. And if we use the same area with a less number of data, what kind of results we can find. Therefore, I'd like to share from the Japan's one of the case study from Japan. This is the Saitama city in Japan, very near the Tokyo, and the total area of this city is around 220 square kilometer. And in the same map, you can see some micro topography. For example, the topography is not too varied like in Nepal. It's almost floorland or almost very plain area. And only the topography difference between 3 meter above mean sea level to 18 meter is almost flat in these 220 square kilometers. Just there are some terrace and some lowland. In the same area, the geology of this area is only two types of geology. There is no rock, only terrace land and lowland. Lowland means you can see here in these maps, there is yellow color is a lowland and brown is a terrace land. And the age of these two sediments are different. One is Holocene sediments and another one is Paleocene or older sediments. And in the same maps, in the same area, there are historical earthquakes happens, and then this study was focused on the liquefaction study. Therefore, I recorded, you can see in the right maps, there are some blue circles and triangles. These shows the liquefaction observed in the historical earthquakes in 1931, 1923, or yeah, in different earthquakes, they observed the liquefaction in these areas. And this is the soil found in the depth from these terrace land and lowland. I want to show you these cross section AB and CG. You can see here in the left image, and then along these lines you can see the thickness of the soil, sandy soil, silty soil, or clay soil in these cross sections. And then you can see here from western side to eastern side and north to south is in the western side there is thick sandy soil, and in the eastern side there is thick clay or silty sand, silty material or fine material. And in the northern side there is thick sandy or coarse grain material, and in the southern part there is silty material, sandy silt material. And this is the study area I showed you already. And then in this area, actually I pick up some of the boreholes for the liquefaction analysis. You can see in this image, in this figure, two types of boreholes. One is blue color and red color. The blue color are the first set of data. They are around 86 boreholes covering all the 220 square kilometer area. And red dots, there are 40 boreholes, there are 220 boreholes. Actually, in these boreholes, I collected all the geotechnical information available, and then from the both boreholes, and both the boreholes are independent each other. First, we collected first set of data, and we use these first set of data to prepare the map of the liquefaction potential distribution in the Saitama city. And then the second set, the red dots, second set of data we use to validate the results, how the results, interpolated results can be matched with the real measurement data. Therefore, all these data were, some of the data we collected from some consulting company, and second set data we downloaded from the link I have provided at the in this slide. And after collecting, actually I'm not going to talk about how the liquefaction potential calculated or measured or something, but I just wanted to show how the data number of data affects the results. Therefore, in these first set of data, you can see here after calculating liquefaction potential and putting all the boreholes, you can see here the liquefaction potential is varied in all the points and everywhere. But our theme is actually in the data scarce region. For example, in the borehole points, we got the liquefaction potential value to design our infrastructure or our buildings. But if there is no data available, no boreholes available, in this case, we have to interpolate the data. We have to interpolate the results for these scarce region, no data available points. Therefore, in this theme, for example, if we have the borehole points as these, like these dots, and we have to evaluate the data in other areas, like for example, in the middle points is in these area. I'm not sure you can see my arrow or pointer or not. Yeah, in this area, and then yeah, though there is plenty of research around the globe about liquefaction potential. Yeah, this is one of them, and we have to evaluate liquefaction potential for all area, for all the color area is important. We have to interpolate for these data. Yeah, there are different methods of interpolation actually, but I use the I use the kriging method of interpolation here, and then in this case, we use the surrounding borehole points to interpolate the value for the any unmeasured or unsampled points. You can see here in this image, the red dots, they are the sampled borehole points. Around these, the green dot is interpolated points, or we have to interpolate these points. Therefore, this equation is used to interpolate. I'm not going very depth in the kriging as well. And then N is the number of points and surrounding points, and PL XY is we have to interpolate for these points, and then PLI is the measured liquefaction potential or in these points. Yeah, these are the scenario. And for interpolate these green points, we have to determine the lambda value in this equation. This lambda value determined by this interpolation, some techniques. For example, if there are some sample points surrounding the area, and then the difference of the liquefaction value, or in this case, I tell the liquefaction because this experiment is done for the liquefaction. Therefore, I tell you the liquefaction for these points. But same case we can use for the other soil types or soil other informations, or CRO velocity, or VS30, or PGA, or any kind of value is the same process. Here I use the liquefaction, therefore I tell you the liquefaction, yeah. And using this curve, the variogram curve, we can interpolate. We can find the trend curve or lambda value from these equations. Actually, I'm not going very deep in these equations as well. And we can find these curves. And it shows how much distance is affected. For example, if you want to find the liquefaction potential value at one point, and how far is the affected points, or which sample borehole you can use, is depends on the availability of the data and complexity of the geology as well. Therefore, in this case, just I showed you on the variogram, and this is the scenario, or this is the methods how to interpolate. Therefore, in the interpolate, if you have enough data, enough informations of your data, you can use these kriging methods as the isotropic and isotropic ground model as well. For example, in the top affects the similarly in your required point. But in certain area, in certain ground, in some direction, in certain direction, there is similarity. For example, in the geology, some formations extend in the one direction. In this case, similarly, in the extension direction, there is similarity in long distance, and another is perpendicular distance, there is dissimilarity in the very near. Therefore, at the bottom, you can see in the blue axis, there is even in the short distance, there is dissimilar in the value. And in the red axis, you can see the long distance for the similarity of the data. It depends on the ground model. Therefore, if you have enough data, you can test in these isotropic or anisotropic data model as well. And then in this case, you can see the variogram, two kind of variogram. One is very short effect distance or range value, and another red is a long range value. And then we can interpolate, we can find the data value for our required points. Here, the result of these previous maps. Actually, in the left, this liquefaction potential distribution map prepared by the isotropic ground model of this ground. And then, as I already told you, the blue dots used for the map preparation, and then red dots for the matching or validation of this result. And then we again went to the site, we pick up the liquefaction potential, interpolated liquefaction potential, and observed liquefaction potential on the red dots. And then we compare the results. It shows the value 0.74 is the regression coefficient. And then similarly at the left side, right side, you can see this map prepared by the anisotropic ground model, and then in one direction there is similarity in the long distance, and then we prepare the map, and in this case we found the observed and interpolated results is 0.78, means more than the isotropic ground model. It reflects, if you have enough data, you can do the very minute research, minutely you can analyze the data, and then your results is more better. If there is not enough data, for example, very few data in this area to prepare the map or analyze the map, you cannot do the either there is an isotropic or an isotropic, because you did not have the enough data to analyze this kind of informations, this level of informations. Therefore, if you have enough data, you can do this kind of minute research, and your result is more accurate than previous one in this case. Therefore, is first I compare these results with interpolated and directly observed data, and you can see the results. Similarly, at that time, you all knows that the Tohoku earthquake hits Japan on March 11, 2011, and then at that time, yeah, the Japan was severely affected all around the northeast coast of Japan, and at that time my study area also hit by that earthquake. And then all the area I visited, after I prepared these maps, I visited this area, and then I took some photographs. You can see here, this area was liquefied during that earthquake. That means we prepared, we have the enough data, and then we prepared the map. That map was quite matching with the real ground, and then this area was, again, we can validate this map with these record as well. That means, oh, the prepared map is more reliable than if there is not enough data like this. In this case, our map cannot be more reliable than the much data we have at that time. Therefore, I use the effect of change in number of data for the interpolation. At that time, I used, as I told you, there are 86 data and 40 data for validation. And I use, if I reduce the number of data for the interpolation, what happens in the result? And you can see here, the top, there is, I use the 0.36 number of 0.36 data per square kilometer is, we found the R square value is 0.64. Similarly, 0.27 data per square kilometer is 0.47, and 0.18 data per square kilometer, we found the 0.33, and 0.09 data, very less amount of data for interpolation, we found the 0.06 R square value. It means if you have much data, you can interpret, you can prepare the better result, and then you can make the policy. Oh, what happened and what will be happens in the future. Therefore, without data, we cannot do actually, because, yeah, and then you can see here how it's the R square value with the number of data set is, you can see here the data, if number of data increases, the regression or the coefficient of regression is increases with the data of interpolation. Interpolation is increases. And then similarly in this area, I to be unbiased, I mix up all the data together and divide half, and then half data, 63 data is used for the interpolation, and second half of the 63 data is used for the validation. And then I found the red triangle you can see here at this curve is quite matching with the result I prepare. Therefore, the number of data is very important to prepare any kind of disaster, because liquefaction disaster is one disaster. Therefore, any kind of disaster maps, risk analysis map. Therefore, data is very important. For our Nepal case, yeah, we all knows that Nepal is earthquake prone area, and during earthquake, why the earthquake prone area, it's already everyone knows about this, the tectonic activities and everything. And due to this earthquake, we can see different disaster. You can see here these photos we collected during our survey, and then some of them from the Kathmandu city area, and then some of them from Melamsi area, and yeah, at the Kodhari area. Therefore, yeah, these images shows the disaster in Nepal and in Himalayas region, in Kathmandu and all around Nepal. And you can see the landslide in these damage. If you want to study these landslide, there is no data, no information. How can you mitigate and mitigating measures to these landslides? Therefore, if you have plenty of data, the landslide, when it happens, how it happens, and when and how much rainfall was happened in this time, and then how much mass was wastage, and this information will be very helpful. If we had these informations, we can interpret, we can prepare these maps for the future. For example, in this Ramsey landslide, you can see there is two roads. Actually, as I know, this bottom one, this road is shifted downward with age, with years by years. Therefore, they constructed the upper one. At first, that bottom road was slightly upper side than current position, because we fix some GPS points along this road, around 18 GPS within these 500 meter sections, and then we regularly monitor these GPS, and we found this mass is shifting, moving downward, very creeping, that was very slow rate, around as I remember, I didn't put this data here, around 30 centimeter per year. Yeah, this is another one is a Judy landslide. Everyone aware about this, and it happens, and many people's killed in this landslide. And these images is very recent, and the Prithivi highway was damaged in this during these rainy seasons. And you can see here very stupid reasons. And if any geoscientist, if he recommend, if he saw this house in this middle of the floodplain, no geoscientist recommend him and to construct his building there. Therefore, without the geoscientist knowledge and informations, yeah, this kind of stupid activities can be happens. For example, landslide on the highway, and we construct the highway, and then we forget to protect the slope of the side of the highway or downhill side. Therefore, this kind of activities happens. For example, in this bridge, you can see here the bridge dam is Mewakola maybe, and actually, if any geologist or geoscientist, if he monitor very carefully at the upstream side or catchment area of this river, and monitor or gather the information how much debris can be carried by this river, or recurrence interval of the rainfall in this region. If he monitor, or he has the past data of these informations, of course, the size of the river of this bridge can be, they make some larger size or higher or something, they can change. Therefore, it happens because of the size of the drain is smaller than its volume. Therefore, it happens. Therefore, we did the similar works for the Kathmandu Valley actually. Therefore, I want to connect my previous study in the Kathmandu Valley. In Kathmandu Valley, previously, there are very few data available for the geotechnical analysis and for liquefaction, not only liquefaction, other BS30 informations or some PGA informations. There is no data to prepare our mind, to prepare our policy, what kind of informations are we have to add for the maps. Therefore, these are initial case. We have very few data and we prepare this map. But our idea is we have to collect or we have to add some data for the Kathmandu Valley case. Therefore, you can see here some of the boreholes data we added from our project, the SAFER project. We are working in Nepal, and then we did one borehole at the center of the city, the Dili Bazar Padma school, and then at the same school we measured the BS30, and then you can see the result here. And you can, these are the results. If you like to see the details of these results, photographs and others, you can go to this paper underlined, this Gilder et al. Our paper is already published about this. And then similarly, we did the test in the Bijeshwari near Swayambhu, and then we found the soil log and the soil informations, all kind of informations we have, and we measured the SPSR methods to find the depth of the bedrock and different kind of soils. And then you can see, if you interested, you can find this paper online, Pokhrel et al. And Gilder et al., both the papers, you can find these information as well. And therefore, in Kathmandu, if is in the previous slide, you see just very few data. Therefore, we planned to collect all the data, how much data we can collect in the Kathmandu, because we can collect from some company, some consulting company, or some reports, or some NGO, INGOs, and then we collected, we requested them for the collection of data, and then we collect this much of data, 591 data we collected in Kathmandu. And these are different sources. You can see some industrial reports or research. These are different sources of data. And if you like to see, you can like to analyze your research relating to these data, you can find this data. I'll show you the link in the next slide. These are the points where we collect the data for the Kathmandu Valley. You can see here a lot of boreholes than previous one. Therefore, using these boreholes, these are different depths, different information. Some of the boreholes are just holes and has the information of the soil only. Some of the boreholes has the SPT value or some geotechnical information. Some of the boreholes has the BS30 measurement as well. And then, there are different informations we collect and we put for availability for everyone, and you can find in the website. Therefore, this is the database, and then this database can be used everyone. Is that very important for disaster mitigation. And these are some data, some boreholes with BS30 measurements. We have 18 boreholes with these informations in the Kathmandu Valley. You can find this information in this database. And this is the database manual published with this link. You can go this link and you can find this manual and all the database in Excel sheet as well. And these are the examples of the how we write in this database. Actually, the database is based on the, maybe you all know, the AGS is the Association of Geotechnical and Geo-Environmental Specialists. is published in 2017. We all the database are based on this AGS format. Therefore, you can find very. I hope you will easily understand these database. What kind of informations are there, and how can you use this data? And these are some results from these database, and these results we already published in paper in earthquake spectra. You can go this paper, and these are also free available for the online. Everyone can access these results in this paper, and these are some results of these informations. And then not only these, we planned to optimize the data. We have to optimize as we can. Therefore, we planned to do the test of the site, in situ site investigation. Actually, this kind of test is new in Nepal. And this is the CPT investigation, but it's different than other CPT. We measure both CPT test and BS30 test for example, pore water pressure or shear modulus of the soil, and a type of soil, and yeah, there are different results. You can find these information as well in the database. This is I wanted to share these photographs, how these tests we did in the Kathmandu Valley. You can see here the CPT rod we inserted from the hydraulics of the, at that time we used the bulldozer. Therefore, bulldozer's hydraulics we used to push the CPT cone and the seismic cone, and then we measure. You can see here the hammer to hitting sidewise and down, and then vertically and side, and then you can measure. We measure the shear wave velocity and P wave velocity both, and then we collect the data for P and S wave measurement. And actually, what we found in this research is for the BS30 distribution map or PGA distribution map, everyone based on the USGS map, but the USGS BS30 measurement interpolated or BS30 distribution map proxy of the slope. Actually, these USGS map based on the proxy of the slope. Therefore, in the Kathmandu, they prepare the map for the BS30. But if you measure actual site by in situ measurement or other downhole methods, the data, the value is much lower than the USGS prediction map. Therefore, this, if you measure in the real site, real value, this data is more much better than the map based prepared based on the proxy of the slope or any other only soil types. Therefore, the data, how important is the data measured in the site is we found in this test as well. And then after, based on these, all the informations, all the data, we prepare this cross-section of the basin topography of the Kathmandu Valley, because these in these basin topography section of the valley, we use the previous microgravity survey made by the Moribaisi and Mauro, and then our data, and then microtremor analysis by Paudel et al. And then all these information we gather, we tally with this data, and our collected data, boreholes. Some of the boreholes are more than 500 meters, and some of the boreholes 300 to 400, 300, yeah, different depths. Therefore, those boreholes which meet the bedrock, we use these boreholes to interpret the basin topography. And then, yeah, we prepare this basin topography by using these boreholes. And then, yeah, you can find these in the same paper, the spectra paper already published. And yeah, these are the information I wanted. Therefore, I prefer, if you can collect, you prepare much more data organized in the database. It can be helpful for policymaker or any researcher, and then this is the and any others. This is the one example for the Kathmandu Valley, and one example for the geotechnical database or geological database. But same kind of database, same kind of process for landslide or hazard, flood or any others, earthquake or any others. We have to do the same process, same database. Yeah, we have to either we have to request for some government authority, for example, YANSET, NAST, or some Ministry of Education, some department of there, they can collect or monitor, or some add the how to say, prepare the database. I'm not sure who are the authorized body to prepare this kind of information in Nepal. Therefore, these are the information I wanted to share. Yeah, thank you very much for your kind attention. Keep distance, stay safe, save lives.
Thank you, Dr. Pokhrel, for your enlightened presentation. And this is the most important areas where we have to work. Can you just close your screen sharing?
Yes.
Okay. Yes. The most important thing is that to collect the data, and the more important is that to make publicly available those data.
Yes, exactly.
after the project. This is the major thing that we have to look on, and for this to come. And most of the time, what we are always talking about, we didn't have institutional memory in the country. And so that we have to go forward to make more metadata, or web-based platform where we can store such kind of data, where we can utilize this data for maybe what you have rightly mentioned, that you generated such kind of really good data from the SAFER project, and which is already ended, and but these data we can use for other analysis, for maybe for liquefaction, maybe for other geotechnical investigation, or maybe for the metro what we are proposing in Kathmandu. And your examples from Japan, rightly clearly explain the importance of the good database system in the countries or areas where we have good or scarce database. Thank you once again. I mean, there are a couple of questions in the Zoom chat box as well as in Facebook. I will take some of them. So one question from Province Frester is asking, how about the accuracy of interpolated data from kriging method? Can you just explain a little bit?
Yes, the accuracy is, I already showed in the graph. And in this graph, if actually interpolation is only the using the available data, it depends on the how many data you have are available data, and the interpolation depends on the available data. If you have plenty of available data or surrounding data, the interpolation is almost more than 90 or 95, almost 100%. But if the surrounding data, the neighborhood, it says neighborhood data, if there is very few number of neighborhood data, 1 or 2 or 3, the interpolation is, of course, it's low. The accuracy is low.
Yes, it's the kriging method also is based on the nearest point, what you can do in RStudio or R software or in other platforms. So it depends upon how much data you have, and then you find the nearest proximity of this data. Thank you very much. So another question from Kishore Adhikari is quite interesting because, most of the time when you have isotropic platform or isotropic geology, then, you can interpolate data. But in geology, there are lots of areas where we have, different kind of topography, different kind of rock and different data. So how can we, do interpolation in such kind of environment? Can you just highlight a little bit?
Yes, very nice question. Yeah, it's actually in the real ground. In the actually the isotropic or anisotropic, it depends on the scale actually. But if in your scale of study, if you found the ground is an isotropic, and in this case, the interpolation, you can guide the interpolation in an isotropic direction. For example, if one direction there is similarity is in long distance and another direction is less similarity, then you can pick up the points for the interpolation to the similar directions. Though this is long distance, then dissimilar direction. In this case, you can guide your interpolation in your required direction. Therefore, it will be more better result because I showed you the isotropic and anisotropic for there is the geology was in north-south direction, the similar geology, then east-west. Therefore, in this north-south direction, I guided the interpolation in this direction, some certain angle of azimuth, and then we found a better result than in isotropic conditions.
Yes, thank you, Dr. Pokhrel. And there are lots of questions associated with BS30.
Yeah.
So Province Rest again asking, can you just explain a little bit about the detailed procedure of BS30 methods? And again, similar question away from Govinda Nirola in Facebook is that which method BS30 was obtained, crosshole or microtremor? Can you explain a little bit?
Yes, actually in our database in Kathmandu, all the BS30 measurement was done by the downhole, not the crosshole. It was used the downhole methods. In these methods, we kept the sensor at the bottom of the hole, not bottom, it's a different depth of the hole, and then the source at the surface. And then we hit the ground, and then that vibration measured by the sensor kept at the bottom of the hole or in the hole, and then we had the depth of the sensor, and we have the time of the traveling time of the vibrations. We have time and depth, then we can find the velocity. Therefore, this is a very, very simple way. Maybe you can understand now.
Yeah. Yeah, it's it's very difficult to explain from here, but in the field it's quite easy. So another similar question. So you have explained about the USCS and BS30 data. So is there any correlation between these two data sets?
Actually, we expected that, but there is no correlations because all the USGS data are higher than real measured data in the Kathmandu.
Okay. So from Ajay Rautela, if we can take the landslide data, so from where we can take? I mean, we don't have such kind of landslide data set still, but it's preparing on. But after the Gorkha earthquake, I think there are some data set exist freely available. What do you think, Dr. Pokhrel?
You mean the landslide data? I hope, they are available in some of the universities. I'm not sure. I didn't check how much data they have, but I hope you can find some landslide spatial distribution of landslide data. Yeah.
Yeah. Now, after the Gorkha earthquake, from Nepalese landslide, there are available. For example, we have done our work, and this is also available. And from Roback also, there are landslide database. But for the longer term, on spatial way, the landslide data are not available from the Nepalese side. And the USGS is working somehow to collect data. And yes, some of them can be found, but people are working on. That's good. So, I mean, there's another question from Susan. He's asking, how do you validate your interpolation of this method? But it's still, I have something in my mind. What methods that you use to validate the BS30 with the interpolation result? For example, dispersion curve also gives the BS30 based on BR40, and how to validate this data. Can you just elaborate on it?
No, the for BS30 is the similar, because is you have the some data spatially distributed in your study area. In this case, you can interpolate all other points, like interpolation is like isotropic or anisotropic, it depends. And then for the validate, of course, you have to go and measure the site is the most important or most best way to validate. Otherwise, if you measure, you have very few data. For example, in Kathmandu, we have just less than 20 data with BS30, and then how much data we use for the interpolation and how much data we use for the validation. Therefore, in this case, we just can prepare the map. And then it's just my opinion is the map prepared, because now the BS30 data we have is 19 of the downhole methods, and 9 is by the CPT seismic cone methods. Therefore, we have altogether around 28 data. Therefore, we can we try to prepare this by BS30 downhole methods, prepare the map, and CPT cone methods validate the data. But CPT cone still they measure lower than the in situ measurement shows slightly lower than downhole methods. Therefore, in my opinion, the in situ measurement has the higher accuracy than downhole. Therefore, for the validation, it's not easy task actually. We cannot, because if you have plenty of data, you can validate with new data. Otherwise, yeah, there is no options.
Yeah, sometimes CPT is, sometimes empirical one, and we have to be very, very careful on that. Similar in the range of this discussion, there is one question from Sony Pradhananga asking, what other method have you used addition to SBSR or BS30 that is mostly used in seismic wave, or any use of GPR or ERT?
For the BS30 or for the BS measurement, we cannot interpret or we cannot measure by electrical methods and not the GPR. The best method is either in situ measurement or downhole, crosshole, or in other seismic methods, or SBSR or microtremor. Yeah, they are the best way. The microtremor is not too much reliable compared to downhole. Of course, downhole is more expensive and more time consuming and more reliable, because we can compare with the soil information as well, because we pick out the from the borehole we take the soil sample as well. Therefore, yeah, of course, but no other methods to measure. Yeah, microtremor is somehow we can use.
Okay, so another question from Anuj Khanal. So asking, I was curious if your Shaper project had developed compaction and consolidation coefficient for the Kathmandu soil, because writing that, Anuj is writing that they are doing new project and in Kathmandu Valley addressing land subsidence issues to aim the developed database on geotechnical, hydrogeology, seismic, MAM, MSW. Any suggestion how you proceed with database structures? Do you have any kind of format that you have prepared? Something like that? Anuj is
Yeah,
asking about that.
yes, but yeah, we prepare the database and it's available for everyone. Yeah, there is format is, as I already told, AGES is the Association of Geotechnical and Geo-Environmental Specialists. Yeah, and there is one format to insert all the informations in the website and in the web. Therefore, yeah, you can find in this web.
So have you tried to find, derive compaction and consolidation coefficient from your database?
Not it, not it. We didn't try this.
Okay, yeah. So yeah, I mean, yeah, there is always,
Hopefully in future we can do that.
yeah. I mean, it's
Yeah.
always there's room for improvement, and
Yes.
yeah, the most, Dr. Pokhrel, what I think, your work on SAFER or in other work is always good, but in terms of to understand the science, in terms of to understand the soil properties, or for example, the Kathmandu Valley, the thickness, the soil changes, which is linear and non-linear. It's a long discussion, after the Gorkha earthquake. So sometimes people are quite afraid that, is your data really good to interpret something, or how can we go forward such kind of database, or how can we improve your database? So can you just elaborate or discuss on it a little bit?
Yeah, very nice. Yeah. Actually, the geology, the soil profile in Kathmandu is so much complex than I think any other part of the world. It's very complex because maybe I showed you in some slides. The soil profile, even in the millimeters, there is changing. Few millimeters of clay and then sand and then clay and mud or some, it's coarse grain. Therefore, within 30 meter, 20 meter or 10 meters, there are complex geology. The soil profile is very complex and it's cannot exactly matching with the nearby locations. It's very difficult. Therefore, it depends on how accurate you want to do the test, or you want to do interpret. If you want to very exact, of course, you need to test in your location. For example, if you want to know what is the soil nature, soil properties of this point, you want to construct your house, and then you have to drill. You have to go drill, or you have to test by yourself. But if you want to just know what is the common soil nature in Kathmandu or in your locality, of course, these methods is suitable.
Yes, thank you, Dr. Pokhrel. And I have some other discussion also, but in the meantime, I would like to request two persons who raised their hand, but I would like to ask them, please write your question, because we don't allow participant to ask question in verbally. So I would like to request, please write down your questions, and then we'll address that. So in the meantime, Dr. Pokhrel, what we are, thinking in Nepal, that most of the time when we are doing a, bigger project, for example, development projects,
Yeah.
for example, road or, other infrastructures, big hotels and others, most of the time we are ignoring the large scale of geomorphological
Yes.
phenomenon, for example, large watershed, or the large landslides, or the for example, the liquefaction potential that what we are talking about here in Kathmandu, and people are often ignoring. The ignorance can be from two sides. Either one thing is we don't have database,
Yes.
and the another thing is that people, they don't want to use those database because they are not really keeping these scientific understanding to develop a project. So what's your opinion on that? Can you just comment on it?
Yes, I also have the similar experience in the past as well, and especially in Kathmandu, in our country, the developers, yeah, of course, they can use, if the first reason is no data is a big problem, because they didn't want to share their data, and they didn't want to use and share our data as well. Therefore, there is the problem with sharing each other. Because if you prepared, for example, I share you these data and these informations. If somebody use in the future, this will be good for the development and for the better settlement. If nobody use, what can we do? Nothing. Therefore, we can just suggest, please don't ignore the geoscientist, or don't ignore this research. This is scientific findings, because in foreign countries, either I work in Japan and in UK, every people, every politicians, or every government bodies, they follow the scientist, because scientists always better than others. Other means, I mean, the policy makers are, they always follow the science, follow the scientific results or technology. But in our country, nobody cares about this. Nobody cares about what is this. This just publications and just papers and research. We cannot use this. Therefore, yeah, this is the problem with
Yes.
our policymakers.
Thank you for your diplomatic answer, Dr. Pokhrel. So another question from Dilliram Thapa: Can we use drilling data for BS30 empirically?
That is is similar with interpolation. Actually, yeah, with the drilling BS30, of course, we can prepare some correlation coefficient or correlation equations for the soil type. Because if you drill one hole and then you found what is the BS30 value for what kind of soil. For example, for clay about 100, or coarse sand is about 150. If you found real data from one borehole, you can just correlate with these data with another drill holes. This is just correlation, not the exact measurement, but you can correlate somehow. Yes.
Okay,
it's
thank you.
Better than nothing.
Yeah. I mean, we have to work a lot because it varies from different place to place and depends upon the rheology and subsurface geology of the area. So I think we'll take the last question from Gokhan Kijili Mark. So can you just elaborate how the uses of remote sensing techniques in terms of disaster mitigation or geotechnical investigation somehow?
Yes, as a remote sensing, of course, for disaster mitigation, for example, some landslide, if you use the aerial photographs or aerial image, you can see what is the topography change, or how is the morphology changes. Morphology depends on, of course, it reflects something. Micro morphology or mega morphology, yeah, it reflects some superficial activities on these images. Therefore, of course, remote sensing can do. And another one is these images or remote sensing data, they can be interpreted, for example, after mega disaster like Gorkha earthquake or Tohoku earthquake, and after these some data, because during my postdoctorate study in Japan, University of Tokyo, I did some study about the ground subsidence after earthquake and before earthquake, because the data they collected before the earthquake and then the level of the surface, that means elevation, and then immediately after earthquake they again measure the elevation of the ground in very accurate way. In this case, I found after liquefaction, severely liquefaction in this coastal side, and then the ground, the road, the buildings, they are subsided by few centimeters to, about 70, 80 up to 80 centimeters. Because in my paper, you can, if you are interested, you can see some in my papers, the road subsidence. Therefore, remote sensing is very important, of course, and it reflects as a whole at a time. Therefore, not all. For example, if you want to test the soil nature, soil type, of course, the remote sensing cannot do that. But some of the other informations associated with these surface activities, we can collect. It's very
yeah, absolutely. Because, after the Gorkha earthquake 2015 Nepal, when we saw the panchromatic images, then we could see, the upliftment and subsidence, the Kathmandu Valley, northern part of Kathmandu Valley and southern part of Kathmandu Valley. So yes, remote sensing always helps to understand. Even, if you use the INSAR data, then you can measure very accurately the land deformation to understand the geomorphology and others. Thank you, Dr. Pokhrel. It's a marvelous presentation, and we learn a lot from your expertise, and we always happy to see your work for the Geo-Science database development in days to come, and other thing. There are always room to improve, and there is always room for the improvement in days to come. And I'm pretty much sure that we'll work together for the development of projects or research or some other things. So I think I have one last question from you. No. So yeah, thank you, Dr. Pokhrel, and I would like to thank you once again. And do you want to say anything at the last?
Yeah, thank you very much for providing me this platform to share my knowledge and share my information, share my findings, and hopefully this database, if anybody interested, they can use freely available for everyone. This is very important for the Kathmandu and in Nepal. Therefore, I hope this will be helpful for any interested persons, researchers in Nepal as well. Thank you very much for providing this platform. Okay.
Yeah, thank you. And so Suraj, the Executive Director of Institute of Himalayan Risk Reduction, thanks for providing me to moderate this session. And I complete my moderation. Please, Suraj, go ahead.
Thank you so much, Dr. Prasanta, for the excellent moderation and making this webinar session very much lively. It's always a pleasure hearing from you. And we'd also like to thank Dr. Rama Pokhrel sir for this wonderful review of the work that he has been doing. And it was really interesting to see how the limited data can be used to aid the results and provide some very interesting findings and outputs. The insights on data optimization, interpolation were really informative. We'd be really happy to work and collaborate in the coming days. The Q&A session was also really interesting with a high number of quality questions. We tried our best to address all of these questions, and we took the questions from the Facebook page and Zoom chat box both. So I hope the queries has been solved. And in case if you have any further queries, you can also mail to us at info@inhrr.org. So I would also like to convey my big thanks to all of our organizing team, speakers, session moderator, our distinguished guests and participants for participating in this session. The session was really informative and interactive. We'll be sharing the recorded session on our YouTube channel, and the links will be forwarded to the registered email. We have a long way ahead, and we'll be very much happy to collaborate and coordinate with the number of organizations to aim for the sustainable risk reduction. We'd also like to request our participants to please fill up the feedback form and also suggest the future webinar topic with us so that we can also address your request. We'd also like to mention that Institute of Himalayan Risk Reduction will be more than happy to organize this kind of relevant webinar in the coming days. So with this, I would like to sign up from our session for today. So thank you once again. Namaste. Have a great time.